A really useful tool with calculus at the moment and for your future is looking at exact values. That is, whenever you know a value of a sine, cos or tan of an angle, there's a few particular angles that we know some exact answers for, instead of a recurring decimal. Why is this useful? Well, you know I like fractions instead of decimals, but also quite often you'll find that various parts of fractions will cancel out, or you'll get nice easy numbers, whereas with a horrible decimal you never know what you're looking at. So, here's the first tool. Let's consider an equilateral triangle. I'm going to make all the sides 2, you'll see why in a minute. Let's say that all sides are 2 lengths, and you also know that the angle are all going to be 60 degrees. If I drop an angle down there to the middle and cut the triangle in half, I'm going to end up with a right angle triangle. Obviously I can now split that base in 2, so the base of my little triangle there is only 1 unit long. That's why I made the sides 2 to start off with. So now I have a side of 1 and a side of 2. I can work out the third side of my triangle using Pythagoras. 2 squared minus 1 squared. I get square root of 3 for that height of my triangle. Also, obviously, I know the other angle at the top here now is 30 degrees. Please remember, those are degrees. So if I turn those angles into radians, 30 degrees is going to be pi divided by 6, because if you remember, 180 degrees is the same as pi. So 30 degrees, 180 divided by 6, pi over 6. The other angle, therefore, will be pi over 3. The reason it's important to remember that, as I said, most of the stuff for this topic is in radians, and also this exact values triangle, which is on your formula sheet, gives you the angles in radians, not degrees. Make sure you can convert. So, I've got a right angle triangle here. I know both angles and all 3 sides, so I can look at some trig ratios. I can now see that sine of 60 degrees must be opposite over hypotenuse, root 3 over 2. Cos of 60 degrees will be a half, and tan of 60 degrees will be root 3 over 1, root 3. Looking at the other angle, sine of 30 is a half, cos of 30, root 3 over 2, and tan of 30, 1 over root 3. Nice exact numbers. If you were to do the square root of 3 on your calculator, you'd get a recurring decimal. Not a nice answer. So the exact values are much simpler. The 3 basic angles that you're going to look at with exact angles are 30 degrees, 60 degrees, and the other nice one is 45 degrees. So let's look at that. Okay, so to get a 45 degree angle, I need a right angle triangle. And if that angle's 45, the angle at the top is also 45, which means the 2 opposite sides, thinking about sine rule, must be the same. So let's call them both 1. But also remember, 45 degrees in radians is going to be pi divided by 4, 180 divided by 4. So there's my 2 sides, both 1. There's my angle, 45 degrees. Well, hang on, I can work out the length of my hypotenuse, Pythagoras, 1 squared plus 1 squared. The length of my hypotenuse is root 2. So now I've got 3 sides of my triangle, I've got my angle, so I can get my trig ratios. Sine 45 degrees is 1 over root 2. Cos 45 degrees is also 1 over root 2. And tan 45 degrees is 1 divided by 1, it's just 1. Useful ratios to look at. Again, this triangle is also on your formula sheet, but now you know where it comes from and what it's useful for.